Hello everyone. In our unsupervised learning, we are going to look into the topic of clustering, mixture of Gaussian, normal or Gaussian distribution. Many data sets can be modeled by Gaussian distribution. It may be univariate or multivariate. Uni means single, multi means multiple. So it is quite natural and intuitive to assume that the clusters come from different Gaussian distribution. Or in other words, we try to model the data set as a mixture of several Gaussian distribution. So this is the core idea of this model. In one dimension, the probability density function of a Gaussian distribution is given by f of x is equal to 1 by sigma by root 2 pi e power minus 1 by 2 x minus mu by sigma the whole square, where mu denotes the mean and sigma square denotes the variance of the distribution. Next, we are moving into the topic of Gaussian mixture model. A Gaussian mixture model is a soft clustering technique. There are two types of clustering. One is hard clustering and soft clustering. Gaussian mixture model comes under soft clustering technique and it is used in unsupervised learning to determine the probability that a given data point belongs to a cluster. It is composed of several Gaussians, each identified by k belongs to 1 and so on k. So here k represents the number of clusters in a data set. Here your mean mu represents define its center, covariance, summation that define its width. This would be equivalent to the dimension of an ellipsoid in a multivariate scenario. A mixing probability pi that defines how big or small the Gaussian function will be. The mixing coefficient or themselves probability must meet this condition. Summation k equal to 1 to k pi of k is equal to 1. The equation that mixing coefficient must meet this condition is necessary. The Gaussian density function is given by n of x by mu, summation is equal to 1 by 2 pi power d by 2 modulus of summation 1 by 2 exponential of minus 1 by 2 x minus mu per t summation minus 1 x minus mu. Suppose there are k clusters. For the sake of simplicity, here it is assumed that the number of clusters is known and it is k. So mu and sigma are also estimated for each k. Had it only one distribution, they would have been estimated by the maximum likelihood method. But since there are k such clusters and the probability density is defined as a linear function of density, all these k distribution, that is p of x is equal to summation k equal to 1 to k pi of k g x by mu k, summation k, where pi k represents here as a mixing coefficient for kth distribution. So for estimating the parameters by the maximum likelihood method, computing p of x by mu, sigma by sigma, pi by log function. So we are taking log p of x by mu, summation, pi is equal to summation I equal to 1 to n p of xi equal to summation I equal to 1 to n log summation k equal to 1 to k pi of kj g xi divided by mu k, summation k. Now defining a random variable gamma k of x says that gamma k of x is equal to p of k by x. From Bayes' theorem, summation gamma k of x is equal to p of x by k p of k divided by summation k equal to 1 to k p of x divided by k. Now for the log likelihood function to be maximum, it is derivative of p of x by mu, sigma, pi with respect to mu, sigma and pi, it should be 0. So equating this derivatives of p of x by mu, sigma, pi with respect to mu to 0 and rearranging the terms. So here mu of k is equal to summation n equal to 1 to n gamma of k xn into xn divided by summation n equal to 1 to n gamma k xn. Similarly, taking the derivative with respect to sigma and pi respectively, one can obtain the following expression. Pi of k is equal to 1 by n summation n equal to 1 to n gamma k xn. So now we are going to the topic of advantages. Now we are going to see about advantages of Gaussian mixture model. Flexibility. Gaussian mixture models can model a wide variety of data distributions since they are composed of multiple Gaussian distributions. Soft clustering. Unlike hard clustering methods like k-means, Gaussian mixture models provides probabilistic cluster membership, which means each data point can belong to multiple clusters with different probabilities. Density estimation. Gaussian mixture models can be used for estimating the underlying probability distribution of data, making them useful for anomaly detection and other applications. Thank you.